Hello, students. Today is May 24th, our Liberation Day. Congratulations to all of you. Somebody asked me about if we have to consider the weight of the beam in our calculations of the to analyze the result from the lab experiment on the lab beam bending. Okay, so I'm going to explain a little bit on that. Okay, so I'm going to share the screen. There. Okay, so here we have the results of one of the groups. Okay, so we have two results, blue and red. So the first thing that you have to do is you have to get each one of these signals and average in each one of the values according to the applied weight. Now, let's suppose that we have something like this. So that's the average that you are supposed to calculate. So you got 1, 2, 3, 4, 5 values. Okay, so this one here, the very first one, I'm going to call it mu epsilon x 0. That means that right now you have the beam, right? This is fixed. This is here. And there is, the weight is already acting. The problem is that you are supposed to have here the strain gauge, right? The problem is that you zero the signal before applying any force. But unfortunately, there are some errors. Okay, so what I'm trying to say is that this value becomes your zero in everything that you're doing, because right now, there is no load applied on the beam. Okay, so now let's apply the first load. So you apply the first value of the forces on each one of these 2 points, and you have these results. So you have mu x epsilon x1, etc. So what we have to do is we can summarize these results in a table. Okay. Okay, so this is the test. So this 0, that's the original. We have the 1, 2, 0, 1, 2, 3, and 4. 3 and 4. So here I have the values that we have applied. So this is the force, and this is the epsilon x. So this value here is the value epsilon x0, which is this one here, etc. But this value should be 0 because right now we have no load applied on it. Okay, so here I have 0 force. The last one is also 0, but this one should be 0. So what are we going to do? What we can do is we can subtract from each one of these values, we can subtract the first one. So we do this and we subtract the first value, this one here. So this one here immediately turns into 0. So we have a new value, and this is supposed to be 0, but probably it's not going to be something like that. So we have mu epsilon 4. Okay, now we go on and plot the results. So let's assume that all of these values are positive, so it makes me a little bit think easier. So I have the force here, and I have the value of mu epsilon x. So this one here is 0, so it comes here. And we should start. Then we plot all of these values, okay? So we got 1, 2, and then we go unloading here, and finally here. This is supposed to be 0, but this is experiment, so we can always expect to have a little bit of an error, okay? And then we proceed. We can develop a linear interpolation, and what we can do is we can get the slope of this ratio. So here, the slope will be the ratio between the strain or microstrain divided by the force. Now, after doing that, you can solve this problem, evaluate the microstrain as function of the force, and get the same ratio, and compare the slope and the exact value. Okay, so here you can include, let me see if I can change the color. No, I cannot change color. Okay, I cannot change. Let's see. There's no color. Anyway, okay, I'm sorry. And then what you can do is you can plot your theoretical results in here, okay? So I have, let's suppose that we have something like this. So this is theory. So a couple of things. Here, you see that I do not join the experimental values with any line. Why not? Because in every measurement, there is some error, right? So what I do is I can just draw a line, which is a regression from the or to the experimental values, but I do not join them with any line, right? Now, this is the theoretical. The theoretical is known. So we are certain that's the result. That's the theoretical result. And hopefully these two will be together, okay? So here, it's a short explanation of that. If there any other problem with this, please let me know, and I'll try to help you out. Okay? Bye now.